In this video we shall discuss how to deal with situations when we have to calculate some minimum or maximum values. Here is our task. We have to show the book presented in the library with the maximum number of copies. But the trick here is this is not just one task, but three tasks. The first subvariant is just to show any book, the number of copies of which is maximum. The second idea is to show all books, the number of copies of which is maximum and is the same for all these books. And the third idea is to show a book, if it exists, which has more copies than any other book. With our current data set, the result is the same for all three variants of this task. But imagine that we add 10 copies of Eugen Onegin book, so the result will be the next. This is just one book with the maximum number of copies. These are two books with the maximum number of copies, and no book exists that has more copies than any other book. So let's begin with the first variant, when we have to show any book with the maximum number of copies. In MySQL we may select book name, book quantity, order the results by book's quantity in descending mode, and then select just one first record. And that's it. In Microsoft SQL Server, the idea is the same, only syntax differs. We may use top keyword, here it is, so once again we select book name, book quantity, we are ordering the dataset descending by book's quantity, and then we use only the first record. Or we may achieve the same result with such syntax. Also we can select book name, book quantity, order the result by book quantity in descending mode, and then select just the first record. In older versions of Oracle, we may follow the following approach. Of course, it looks rather strange and even frightening, but nevertheless, we may use row numbering to get that first record. And also, we are using ordering in descending mode and then selecting the first record only. But starting with Oracle 12c, this DBMS allows us to use the same approach as Microsoft SQL Server for selecting the first record. Now let's show all books, the number of copies of which is maximum and is the same for all these books. In MySQL we may use two approaches. The first is to calculate the maximum quantity of books in our library and then show only those books, quantity of which is equal to that maximum. The second approach is available starting with MySQL 8. Here is like in sports, when we have the first, the second, the third place, and so on and so on. Rank function places each record on some place here. So we want only those books standing at the first place here. With Microsoft SQL Server we may follow the same approaches. We may calculate the maximum value and then compare the value of each book to that maximum and select only those books with equal quantity. Or we may use the rank function to calculate which book is on which place, the first, the second, the third, and so on, and then select only those books that are on the first place here. And with Oracle the approach is the same, either to calculate the maximum and then select only books with the quantity equal to that maximum, or to calculate the place for each book and then select only those books standing on the first place. Now let's show a book, if it exists, which has more copies than any other book in the library. In MySQL we may follow the next approach. We may select only those books with the quantity greater than the quantity of all other books. This section allows us to analyze only other books, not that book that we're analyzing in this part of the query. This is called correlated subquery. As you may see, this table was renamed into ext here, and the same table was renamed into int here. And we may access either the value from here with ext or the value from here with int, and make sure that the value analyzed in here is not the same as in here. The second approach in MySQL is to use common table expression, it as named subquery, and ranking function. So here we calculate the rank, it as that place for each book, either the first, the second, the third, and so on. And here we calculate how many competitors has each book on each place here. And then we select only those books that are on the first place, and we want that book to be standing alone there, so no other competitors except for that only single book in this place. With Microsoft SQL Server, we may also follow the subquery approach, exactly the same as it was just explained with MySQL. Or we may follow the same approach with common table expression and rank. Once again, we calculate a place for each book, we calculate the number of competitors, and then we select only the book on the first place with no competitors there. In Oracle, the situation is the same. We may use correlated subquery, it as to select a book with a quantity greater than quantity of all other books. Or we may use common table expression and rank, it as to calculate the place for each book, calculate the number of competitors, and then select a book on the first place with no other competitors. The only question remains, which one is faster? And as you can see, common table expression approach is faster here. But pay attention, this is for just this particular case. In other cases, the situation may look different. And correlated subquery approach may be even faster than common table expression approach.